All right, so let's go over how to do some of these problems. So we'll start with this first one. So we want to find a consumer's demand curve for X given some utility function. And so the way we start this, because the convex utility function, is we start with MRS equals MRT. Okay. So MRS here is simply y plus 1 over X, which is equal to PX over PY from the MRT. Normally we would simplify the MRS first, but here it's already simplified, so no need to do that, right? So then next thing we do is we cross multiply. So we get py times y plus 1 equals pxx. And, so now we have a choice to make, right? We can either solve for y or we can solve for x, right? But we want to end up with the demand curve for x, so we should solve for y in this step. So what I'm going to do is I'm going to distribute the py. So we have py y plus py equals pxx. Then we'll subtract the py to the other side. So pyy equals pxx minus py. And then we divide everything by py. So we get y equals px over py times x minus, and so py over py is just going to be 1. Right? So the way you do that is, again, you want to do 1 over py on both sides. You want to distribute this through. So this is going to be the first term, and this is going to be the second term. Py divided by py is 1. Right? Okay. So now you have a relationship of y related to x. So we want to plug that into the budget line. Okay. So we'll plug that in here for y. So we get I equals pxx plus py times px over py x minus 1. Okay. And again, we're going to distribute the py. So we get pxx plus, so the first term becomes pxx, right? The py's cancel out. Second term becomes just py. Good. And so now we're solving for x. So here we have pxx plus pxx. So what you can do here is either think, okay, well, it's the same thing, right? It's 1 pxx plus 1 pxx, so it's 2 pxx, or you can factor out x and see that it's 2 px that way. So either way, you get 2 pxx minus py. Okay, and then we'll solve for x, right? So we add py to the other side and divide by 2px. So we get I plus py plus 2 pxx. Then we divide by px, so we get x equals I over 2px plus py over 2px, which in this problem matches with the answer choice C. Okay, so for problem number 2, this is a perfect complement situation. So since it's perfect complements, we're going to have to do a little bit differently because we can't take the derivative of this utility function, right? So instead, we start by setting up the ratio of C to S. So notice this is not the same thing as change in C over change in S, which would be the MRS. We don't have that here. Instead, C to S tells you how many C's do you need at the same time as you need S's, right? And so in this problem, we need 1 coffee, so 1 coffee for every 3 sugars. So our ratio of C to S should be 1 to 3. Okay, and we simply cross multiply and we get, so 3C equals S, and we'll plug this in to our budget constraint. PS, S. And so we'll plug this in for S. We get I equals PCC plus PS times 3PC. I mean, 3C, right? If we simplify this, right, we'll just write it a little bit better by putting the 3 in the front. So we have PCC plus 3PS times C, right? So we have a C here and a C here. So we'll have to factor it out. And then we'll divide. So we'll divide this whole thing onto the other side. And so we get C equals I over PC plus 3PS, which matches with the answer choice A. Okay, for this problem, we have this quasi-linear utility function, and it says what must be true for her to consume at an interior solution, right? So what is an interior solution? So an interior solution says it's a checklist, and we need both of these things. Okay, we need to have x greater than 0 and y greater than 0. right? That's what it means to be an interior solution. It means not a corner, which means neither good should be 0. Okay, and so we start like normal, we find the demand functions, and this is convex, so we do MRS equals MRT. Here we get the MRS is 2 over X, and the MRT is PX over PY. Cross multiply, we get 2PY equals PXX. And in this case, we don't have a opportunity to solve for Y. We can only solve for X, right? There's only X in here. So we'll solve for X. We get X equals 2PY over PX. And so unlike some of the other utility functions, we have the demand for X came out right away. And that's because this is quasi-linear and X here is non-linear, right? Non-linear. So that means we came up with a demand function for X right away. Okay. So this is the demand. And so we can go ahead and check right now, is X greater than 0 or not, right? Or if it's not, like when is it not, right? So here 2 is a positive number, PY is a positive number, PX is a positive number, right? So since everything here is positive, that means X is for sure going to be positive, right? And so this is going to be checked off always. Okay, so then we should go check Y, right? So we have to find the demand for Y by taking this X demand function, and we're going to plug it into the budget constraint. We'll plug it in for X. Okay, so we get I equals PX times 2PY PX. That's just directly substituting it in. And then we're solving for Y here, right? So we'll first simplify, PX's cancel out. We'll solve for Y, we get Y equals, I guess I shouldn't skip steps. We'll solve for Y. So we first subtract over the 2PY, I minus 2PY equals PYY. And then we'll divide both sides by PY. And again, we're going to divide individually. So we have 1 over PY, and we're going to distribute this to everything, 1 over PY. Right? So on this side, of course, it cancels out. On this side, we have to distribute. And so we get I over PY minus 2PY over PY just becomes 2. Right? And this is going to be our Y. So then the question is, can Y be negative? Right? And so here, Y could be negative because even though the first fraction is positive, it's subtracted by something. And so you can imagine there's a situation where the 2 is bigger than this fraction. So like when I subtract 2, it's going to go negative. Okay. So then the question is, when is Y greater than 0? Right? We want to find when, it says what must be true to be an interior solution. When is Y greater than 0? Okay. So I'm going to clear the screen. We have Y is greater than 0, right? That means that we have I over PY minus 2. This is the demand for Y is greater than 0. Then we have to figure out, based on the multiple choice, what do we have to solve for, right? So we need to solve for, in this case, PY, because if you look, all of these answer choices have the price solved for by itself, right? Not income. So we'll solve for PY. We add 2 to the other side. We'll multiply by PY. It's 2 PY. And then we'll divide by 2, right? So PY and then I over 2, right? And so this one matches with answer choice A. All right, so for this problem, we're given 2 demand functions and we need to prove true or false on all of these statements, right? So let's start with the first one. It says the income consumption curve is upward sloping, right? So for the income consumption curve, we need, just like any consumption curve, we need 2 budget lines, okay? And in this case, the difference between the 2 budget lines is going to be income. So if this is our first budget line, we need to draw our second budget line parallel to this first one. I'm going to draw it outward, but you could draw it inward. It doesn't really matter. But make sure you choose your income in the right direction. So since I'm going outward, I'm doing income is going up. Okay. So 2 budget lines, make sure you change the thing that tells you to change. In this case, it's income for a consumption curve. Okay. Then what we want to do is we want to find what happens to X and what happens to Y when we increase income like this. So we have to check some derivatives. We'll have to check dx di and dy di to find this, right? So dx di here, you can either do it by taking the derivative or by doing the arrow method. So if we take the derivative, we get is equal to negative 1 over 10, which is less than 0. If we do the arrow method, we can see that, the I is right here. So when I goes up, okay, let's just say I goes up, for example, because that's what we're doing on the graph, then this fraction must go up, but it's negative, so that it must be pulling the whole thing down, right? What kind of derivative has this relationship where one goes up, one goes down, so the opposite directions? That's a negative derivative. And so we can find x's dx dy is negative that way. Okay. Similarly, if the arrow method for y, we could say I goes up. So then this whole fraction goes up. Since it's positive, that means the whole thing goes up after that, right? So what kind of derivative has this? That's a positive derivative. We could also take the derivative and we'll get 1 over py. Either way, you should be able to tell that it's positive here. Okay, so we said when income goes up, by the arrow method or by interpreting this derivative, we get x has to go down. And by interpreting this other derivative, we can see that y has to go up. And so on our graph, we have to draw this, right? So we have just pick any point on the first budget line. And what do you need to draw? You need to draw x going down, so to the left, and you need to draw y going up, so up, right? So something like this. So if we connect these points, we can clearly see that the ICC here is downward sloping. It's not upward sloping, right? Because x is going down, y is going up, so you can tell it's downward sloping. Good. So let's go to part B, or answer choice B, I should say, right? So it's another consumption curve, but this time it's a price consumption curve. So price consumption curve, just like an income consumption curve, needs 2 budget lines. So if this is my first one, I need to draw my second one like this, because I need to draw a price change. This is different from an income change, right? So I'm drawing up when price of X changes here, right? So in this case, like let's say PX goes down, for example. And again, I want to find the effect on X and the effect on Y. So for this, I take dx dpx, because px is changing, and I take dy dpx, again, because px is changing, right? So you only change one thing at a time. Do the arrow method or do the derivative. So in this case, the actual derivative is going to be negative py over px squared, which is less than 0, or do the arrow method, you can find it's less than 0. Here, dy dpx is going to be py over 2px squared, which is greater than 0, or do the arrow method, find it's greater than 0, that's fine. Okay, so when px goes down, we'll see that because there's a negative derivative, it has to go in the opposite direction. So when px goes down, x has to go up. Similarly, when px goes down, it's positive derivative here, so y also has to go down because it has to be in the same direction. So x is going up, y is going down. So here we have a downward sloping. Again, I picked any point on the first. So x is going up, y is going down. And so I pick any point. And so x is going up, y is going down. I pick any point on the first budget line. So I'm going to pick this one, for example, it doesn't really matter. I have to go up in the x direction, so to the right, and I have to go down in the y direction. So maybe somewhere like this. And this is going to be our PCC. And this is in fact downward sloping. So this is the answer. This one's true. Okay, good. So how do we check for part C? It says good Y's own price elasticity of demand is positive, right? So own price elasticity of demand for good Y, right? So that's D. So the good is Y, dy, and the price is py. Right? And so we're trying to check, is this positive, right? So we could check here by actually taking the derivative or by doing the arrow method, either way. And we get the derivative is equal to, let's see, negative I over py squared minus 1 over 2px. And so this is clearly going to be negative. And so that's why it's not positive, right? Because when py goes up, y is going to go down, right? It's a negative derivative. Either way, you could do the arrow method or do the derivatives. Okay, now this derivative is going to tell you the sign of the elasticity. You might wonder why we're looking at only the derivative when it's asking about the whole elasticity formula, right? So the whole elasticity here for y is dy dpy times py over y, right? And so why would we just look at this piece? What about this piece? Well, think about py, it's always positive. The thing about y is also always positive. So this whole fraction must be positive. Positive number is never going to change the sign. So we often say the derivative of the elasticity, the derivative underlying the elasticity will determine the sign. And so here we only have to look at the derivative. Okay. And so it's not positive here. It's actually negative. Okay. How would you check if they're complements? Well, actually, we already checked one way. You could check either dx dpy. So this is the cross price derivative, or you could check this other one, which is also cross price derivative. Either way, we already checked this one, right? And we got that it was positive. So in fact, these are substitutes, not complements. Okay. And then good x's angle curve is upward sloping. So we already found this as well. For an angle curve, this has income and a good. So in this case, x on the axis. So we check dx di for this. Okay, we already got this. We got this as less than 0, and so therefore it must be downward sloping. We check this in part A. Question number 5 is very similar to question number 4, except we have to find the demand functions ourselves, right? So here, let's find the demand functions. We do this convex, so we do MRS equals MRT. Okay, we do the MRS, we get, let's see, just y, and we get over 1 plus x. It's equal to px over py. Right. Okay, we cross multiply. And in this case, we need both demand functions, so it really doesn't matter which way you solve. So I'm just going to solve for y, for example. So it's py, y equals px plus pxx. Right, just distribute. Good. And then so we get y equals px over py plus px over py times x. We plug this into the budget line. Okay. So just substitute directly. And then we distribute the py. Okay. Whoops. I equals. Good. So distribute the py. We get px plus pxx. Again, we have a pxx here. We have a pxx there. So pxx plus another pxx. That's going to be 2 pxx. Then we need to solve for x, right? So I'm going to go right here. Right, we're going to subtract by px on both sides. So it's I minus px equals 2 pxx. And then we're going to divide by 2px on both sides. So we get x equals finally I over 2px minus 1/2, right? The px's cancel out on the second one. Okay, good. So this is demand for x. And then we're going to take this. We could either plug it back into the budget line, which would be unadvisable. I would not do that. Or what I advise you to do is plug it back into here for x. Okay, and so then we'll get y equals px over py plus px over py times I over 2px minus 1/2. Right, and so we distribute this fraction through. The first one, the px's cancel on, so we're left with I over 2py. I'll do it over here, I guess. So I over 2py. The second one, we can't cancel out anything, so it's just minus px over 2py. Okay, so we have a px over py minus px over 2py. We can add these fractions. So we get I over 2py. Right, I'll just copy that down. So this one is 2px over 2py, this first one. And the second one is minus px over 2py. So if I do 2px over 2py minus px over 2py, that's just going to be 1px over 2py. So all it's going to be left is this just 1. So we get the demand functions for x and y that way. Okay, so I'll just write them at the top here so that we just have them to work with like the previous problem, right? So I 2px minus 1/2, then I over 2py plus px over 2py. Okay, looks good to me. Great. So it says the PCC as the price of x slopes down, as the price of x changes, slopes downward, right? So again, the PCC, we need 2 budget lines. We need to draw them with the price change in the middle. Okay, and we want to find what happens to both x and y. So we take dx dpx to find the x change. And we find dx dpy to find, So we take dx dpx to find the x change, and we take dy dpx to find the y change. Okay, you could either do the arrow method or the derivative here. So in this case, the derivative is negative I over 2px squared, which is negative, or do the arrow method. We take dy dpx, we get 1 over 2py, or do the arrow method, you get positive. Okay, so when px goes down, what does this say? When px goes down, this says x goes in the opposite direction, which is up, right? Because it's a negative derivative. And then for this other one, it says px goes down. It's a positive derivative, so y also has to go down, right? X goes up, y goes down. So pick any point on the first budget line. I'm just going to pick this one. X has to go up, Y has to go down. So it could be something like that. Okay. And so in fact, the PCC does slope downwards. Right, so A is true. And you could check some of these other ones. So, for the income consumption curve, you check just like number 4, you draw the income changes, and then you check dx di and dy di. In this case, you'll find they're both positive. Okay. Also, you could take the cross price elasticity of demand for good X with respect to price of good Y. So that's dx dpy. Again, the elasticity formula has a derivative portion, dx dpy, and the fraction portion, py over x. But the fraction is always positive, so it's not going to affect the sign, right? We just look at the derivative. So just like the previous problem. And same thing on this last one, you're going to check dy dpy. All right, so for number 6, you could do this just like the previous problem and find the demand functions and then find all this stuff. Or you could know the properties of Cobb-Douglas. So Cobb-Douglas properties, right, that you are useful to know, I should say, right? So you have to know the own price elasticity for both goods. These are all going to be for both goods, is equal to -1. The income elasticity, right, again, for both, is going to be 1. And the cross price elasticity, again, for both, is going to be 0. Okay, so what does this first thing mean? Right, this is negative. So what it really means is that, among other things, is that both goods follow the law of demand. So in any Cobb-Douglas situation, you know that both goods are going to follow the law of demand. You also know, according to this middle one, that both of them are normal, right? Because it's positively related with income. And then you also know that they're going to be unrelated goods. So they're not going to be substitutes. They're not going to be complements. Okay, so you could either find the demand functions here, which I still recommend you should do. But if you know the properties here, you could start cross-conf answers. So you know that they both follow the law of demand. So this is true. You know that they're not substitutes. They're unrelated. So this is the answer. Good Y is a normal good for sure. You could figure out the PCC and ICC and find these are true for sure. And, for this one, you do need to know this, which is that you'll never have a corner solution when you have Cobb-Douglas. So that's why D is definitely true. All right, for number 7 here, what we're going to do is similar to number 5 and number 6. We could find the demand functions or use the properties we know. In this case, we'll just find the demand functions, right? So it's convex utility. So we'll do MRS equals MRT, right? And so the MRS here is 1/2 x to the -1/2. And the MRT is px over py. But, we'd like to simplify this first because, we don't like negative exponents, hard to work with. So this is going to simplify to 1/2x to the 1/2 is equal to px over py. Right? So similar to always, we cross multiply here. And we'll get py equals 2px times x to the 1/2. And we'll want to solve for x. So what we're going to do is we're going to divide 2px on both sides. So we get x to the 1/2 equals py over 2px. And then we can square both sides to get rid of the 1/2 exponent, right? Anytime you have an exponent, do the reciprocal. In this case, it's 2. And you could leave it like this, or you could distribute, which is what I'm going to do. So you get py squared over 4px squared. Okay. And like with quasi-linear normally, this is going to be the demand for one of the goods right away. So this is going to be demand for x. Okay, so you could take this and you could plug this into the budget line, and that would get you the demand for y. But let's go ahead and start looking at some of these properties, and we can see if we can choose an answer right away, right? So let's start with the first one. It says good x follows the law of demand. So we could figure that out by checking dx dpx. And, either take the derivative or do the arrow method. If we take the derivative, we get negative py squared over 2px cubed. And this is less than 0, or do the arrow method, you would find is less than 0. And so this does actually, in fact, follow the law of demand. So we can cross out A, right? It's not false. Okay, good. And then we can check if they're substitutes, right? We could check the cross price derivative to check if they're substitutes. So dx dpy. Here, you could either do the arrow method or take the derivative, but either way, you'd get py over 2px squared, which is positive. So either way, you get a positive derivative. And so, in fact, yes, they are substitutes here. So that's another check. Good y is a normal good. This one we can't check just yet because we don't have a demand function for y, but we could check if x is normal. right? So check dx di. And in this case, we'd get 0, right? Because there's no I in this equation, so we get 0. And so that means x is income neutral. So in particular, x is not normal, right? And that's important here because one of the rules is that if one of them is not normal, the other one must be normal. In this case, x is not normal, so y has to be normal. So this is definitely going to be true. Without even solving for y, we can tell this, right? And then for d, it's saying the consumer will not consume any of good x when py is greater than 4pxi to the 1/2, right? So we're trying to check here, when is it going to be a corner solution, right? When is x going to be less than or equal to 0? When are we not going to consume x, right? So let's just check here. So py squared we know is positive, 4 we know is positive, px squared we know is positive. So this is definitely going to be positive. And so what that means is we're always going to consume x no matter what, right? So that this is definitely false because there's no situation where we would not consume x. This is definitely false because we're always going to consume x. All right, so for this problem, we have a Cobb-Douglas utility function, and we want to find what happens to the consumption of good x when the price of good x decreases by 12%, right? So in particular, when you're looking at percent changes, that's what the elasticity tells you, right? So in particular here, we're looking at the elasticity of own price for x, right? So we're looking at percent change in x divided by the percent change in price of x. Okay, and so this is the interpretation that we're going to use. And then we need a math definition so we can use the utility function and get some numbers so that we can actually apply the interpretation. After we get the number, we can use the interpretation, right? And so the math definition is dx dpx times px over x. In general, all the elasticities are pretty similar in the sense that the good always goes here, here, and here. And the like parameter, so either px, py, or I, goes here, here, and here, right? So it's always going to be that same formula. It's just about what you plug in where, right? So for Cobb-Douglas, if you know the own price elasticity, you could use that here to find the number, or we could go through and find the demand function and do it that way. That's the way I'm going to do here. Okay. Oh, whoops. That's the way I'm going to do here. Okay. So we start with MRS equals MRT. Okay. So it's because convex, right? So MRS here is going to be 1/3 x to the minus 2/3 y to the 1/2. And then MUY is going to be 1/2 x to the 1/3 y to the negative 1/2. And then we want to simplify this first, right? So let's start with the 1/3 and 1/2. So the 1/3 divided by 1/2 is going to be 2/3. What do we do with the negative exponent here? We're going to bring it down. So negative 2/3 is going to go down. So it's going to be 1/3 plus 2/3, which is just 1. So it's going to be x. And then this one's going to go up. Right? Negative exponent flips it. 1/2 plus 1/2 becomes just 1. So it's just y. Good. So that's the MRS. And then the MRT, as always, is px over py. Okay. Cross multiply. So we have 2pyy equals 3pxx. Okay. And then we just solve for one of them. In this case, we want to end up with a demand for x, right? In this case, we're concerned about good x in the end. So since we want good x, we should solve for y at this step, right? So if we solve for y, we get y equals, 3px over 2py times x. Right, so you want to leave x out on the side. In general, you want to separate out your important variables, which in this case is x, versus your constants and things like that are less important, which go here. Okay, we're going to plug this into the budget line. So plug it in over there. Py times px 2py times x. Okay, good. So py's cancel out. We get pxx plus 3/2 pxx. Right? So if I give you one of something, right, one of this, and then I give you another 3/2 of that thing, right, then you have 5/2 total. So 5/2 pxx. Then we solve for x, right? So we divide by 5/2, or in other words, multiply by the reciprocal. Either way you want to think about it, we're going to get 2/5 on the other side. We're also going to divide by px, right? So I'll do that here. We get x equals 2I over 5px. Okay. So now that we have the demand for x, we can use this to find the elasticity. Okay, so we have the demand for x here. So we want to do this in two parts. We want to do part one where we find the derivative. We want to do part two where we find the fraction, and we're going to multiply at the end. Okay, so part one, we're going to take this derivative, dx dpx. Here, the arrow method won't be enough. You have to actually take the derivative. You actually need the formula here. So we take the derivative and we get negative 2i over 5px squared. Okay, then we'll do the fraction. So this is going to be px over x. And for the x at the bottom here, we're just going to take the whole demand function and plug it in there for x. Okay, so we get px over 2i over 5px. Right? Oh, whoops. Didn't mean to write a negative sign there. Good. And so when we divide by a fraction, we have to do keep, change, flip, right? So we have px over 1 times 5px over i, right? So px times 5px is going to be 5px squared. And then 1 times I is going to be I. Okay. So we got negative 2i over 5px squared for the derivative component. And we got 5px squared over I for the fraction component. So we're just going to multiply those, right? So negative 2i over 5px squared. And then 5px squared over 2i. We multiply these, right? 2 i's cancel out. 5px squared, same on the top and bottom, cancel out. So we're left with negative 1. Okay, good. So we got the elasticity is equal to negative 1. And so now let's go to how to interpret this, right? So percent change x over percent change px equals negative 1. And what the problem tells us is that the price of good x decreased by 12%. So it's minus 12 in terms of the percent change of price, right? So it's an algebra problem now. It's percent change x over negative 12 equals negative 1. We're solving for percent change x. We multiply this to the other side. And so we get percent change x equals 12. And so that's answer choice E. All right, so this is a true or false question here. And so we need to figure out the truthfulness of each statement, right? So let's start with statement 1. So it says the income consumption, if the income consumption curve is downward sloping, good Y is necessarily inferior. So let's figure this out, right? So let's draw the income consumption curve here. So we have, we need two budget lines, just like any consumption curve. And we need to draw an income change in between. So that's why I've drawn them parallel here. I've drawn income going up. You could have drawn income going down. Doesn't really matter. And you need to figure out how to draw this, right? So the key thing here is it says is downward sloping. So downward sloping, you have to remember there's two types of downward sloping, right? So there's this type where x increases, y decreases. So something like this. So I'll write that here in blue. But remember, there's also the second type here in maybe in green where x decreases and y increases, right? So this is also downward sloping. Okay, so you always go from the first budget line to the second budget line. So here you can see in the inside, it's a high x. On the outside, it's like a low x, right? So in this blue case, what can you tell me about dy di, right? That's what we're concerned with, to figure out if y is inferior. Okay, in this case, when income goes up, y goes down. So y is in fact inferior. Dy di is less than 0, right? But over here, we have to figure out what happens to dy di, right? In green, when income goes up, y actually goes up. So y is normal. So because there's two different cases here, this one is not true, right? In one case, it would be inferior, but if you forgot to draw the second case, then you would not know that it actually also could be normal. Okay. For statement 2, we have the price consumption curve is horizontal, and we want to find if the demand curve is does slope downward, right? So I'm going to figure that out. This is for statement 2. So we have x and y. For any consumption curve, as always, we draw two budget lines. Okay, in this case, I've drawn a price change because it's a price consumption curve. And I'm going to draw a price of x going down. Again, you could do price of x going up, whatever you like. So we know here it's horizontal. Luckily, there's only one type of horizontal, so no worries about that. Okay, and so when if we just look at the graph from the first budget line to the second budget line, x is going up, y is staying the same. So what can you tell me about dx dpx, right? So we know that they're going in opposite directions, right? Px is going down, x is going up. When things go in opposite directions, we can say the derivative is negative, right? So then what's on the axis of the demand curve, right? The demand curve has x here and px here. So if this derivative is negative, it does in fact slope downward. And so this one is definitely true. Okay, so B is the answer. All right, and so for this last question, we also want to find a true or false. So it says for the first one, if the PCC is vertical, then the cross price elasticity of demand for good Y with respect to the price of good X is necessarily positive, right? So let's figure this out. For any consumption curve, we need to draw two budget lines. In this case, we're going to draw them with a price change. I'm going to draw PX going down. And we know it's vertical. So luckily, again, there's only one type of vertical line. Okay. And so we can say here, X is not changing and Y is going up. Excuse my poor drawing, of course. Okay. And what it's asking about is the cross price elasticity of demand for good Y with respect to the price of good X, right? So in the derivative, we need the good to be Y. So it's going to be Y on top and the price of good X. So the parameter is going to be PX, right? So what can you say here, right? When PX goes down, Y is going up. So in fact, what kind of derivative has an opposite relationship here? This is a negative relationship. So this one is false because it's actually negative. Okay, good. So then for statement 2, it says the income consumption curve is a horizontal line. So let's draw out the income consumption curve. Draw our two budget lines. Income change in the middle because of the income consumption curve. And it's a horizontal line in this case. So something like this. And so we can say X goes up and Y stays the same. So it's asking about the income elasticity of demand for good X, right? So we want to find dx, di, right? This is going to tell us the same thing as the sign of the income elasticity, right? Again, the underlying derivative is going to tell you the sign, right? So here we know income goes up and X goes up according to this ICC. So what kind of derivative has this? This is a positive derivative. So it's not necessarily 0. It's actually going to be positive for sure. So this one is also false. So the answer here is C. Neither statement is true.